Hello everybody, welcome to lesson 9-7, and we're going to talk about factoring special cases. Now, when we learned about multiplying special binomials or cases, I warned you that eventually you're going to have to go backwards. So to warm up, hit pause and just write down the parentheses of the two binomials that would make these products. So in other words, factor these out. Okay, so if we factor them out, this is what we end up with. Remember, what times what is 9, but adds to 6? 3 and 3. So, which trinomials have pairs of binomials that the factors are identical? And the ones in red do, where they're the exact same binomial, x plus 3, x plus 3. And if you remember, that would be the sum of a square. So they basically took this and squared it. They multiplied it to itself. So it says describe the relationship of the trinomials that have identical pair factors. And we remember, we already know this. X squared is here, 3 squared is here, and if we do 3 multiplied to x and double it, we'll get this, 6x. So basically, that's what we're doing. We're going to be taking this and writing this today. So before we begin, just a refresher of our notes. I want you to fill this in. A plus b squared in parentheses would equal what? And I want you to write that in with me. And it equals a squared plus 2ab plus b squared. So basically, like we said before, square the first, write it first, square the last, write it last, and the middle is a times b doubled. Okay, and for minus, it will look like this. We end up with a squared minus 2ab because when we add these together, it's negative and it stays negative. But we do end up with plus b squared because two negatives multiplied together are a positive. Down here it says, how do you recognize a perfect square trinomial? Well, here's how I'll tell you. You look at the first term and you say, is it a square, a perfect square? And is the last term a perfect square? Then, so that's this first part. Then the second part is the middle term has to be twice the product of the two factors. And our example is right here. I mean, we know that x and 5 are the square roots. And if we go 5 times x and we double it, if we double 5x, we end up with 10x. So we're going to do some examples to show this in a better way. Alright, so here's our trinomial. X squared plus 8x plus 16. So it says rewrite the first and last terms, and that's what I'll do. So what multiplied to what is x squared? X times x. And what multiplied to what is 16? Well, 4 multiplied to 4. And then it says, does the middle term equal 2ab? So what I'm going to do is multiply 4 to x, and then I'm going to multiply that by 2 because there's two middle terms, and that equals 8x. Did I get 8x here? Or do I have that there? Yes, I do. So then I know I'm right. And I would like you to write your answer like this, please. If you forget and write it like this, I will accept it. It's just that I would like it's more efficient and concise to write it this way. So the answer is the sum of x plus 4 squared. Alright, here we go. I put our little x helper here. Remember, product, sum, and we can use it for the special cases too. So remember, we need an m here and we need an m here. And what multiplied to itself is 9, and the answer is 3. But if we add them together, they do not equal negative 6. So I'm going to have to put a negative on there. So I'm going to do minus 3. And let's check. Negative 3 multiplied to negative 3 is 9, that product. And negative 3 plus negative 3 is negative 6. That's my sum. So we're going to write our answer like this. M minus 3 squared. A good thing to remember is if the middle is negative, then we need a negative here. Let's look at our next example. We have y squared minus 18y plus 81. Same thing. I'm going to say to myself, what multiplied to what is 81? And it adds to negative 18. Now, you're probably already thinking of this, that we have to have a y here and a y here, and 81 is 9 multiplied to 9. But because there is a negative, I will put that on my 9s. So, negative 9 plus negative 9 is negative 18. So, I can take my negative 9s and place them into the parentheses. And remember, I will write just one answer. My final answer is the difference of y minus 9 squared. And that will give us, the two negative 9s will give us a positive 81, and the two negative 9s added will give us a negative 18. Alright, now I'd like to talk about factoring a perfect square trinomial where a will not equal 1. So the coefficient in front of h squared will not be 1. In this case, it's 16. Well, let's remember our formula. The formula is the sum of a plus b squared is equal to a squared plus 2ab plus b squared. So if I just want to guess and check, what I can do is say, what's the square root of 16h squared? So the square root of 16 is 4, and the square root of h squared is h. Next, I'm going to say to myself, what's the square root of 25, of just 25, sorry. And the square root of 25 is 5. So I'll write my other parentheses. And now, remember, I can check this. Well, one way I can say, all right, a squared. So 4h times 4h, that's 16h. And b squared, I always check the ends first. B squared, 5 multiplied to 5, that's 25. Now this is the step where we're going to check our middle. So we need to do 2ab. So I need to do 4 multiplied to 5, and that's 20h. And now I have to double it because there's two middles. That's where that 2 comes in. And that equals 40h. And if I look right up there, right here, 40h. It works. So now I'm going to write my answer. My answer is 4h plus 5, that quantity squared. Now we're going to practice. So first thing I'll do is I have to identify whether or not this is a square of a difference or a square of a sum. The way I do that is I look at this term and I say, can I square root 9? Yes, I can. It's a perfect square. And can I square root a squared? Yes, I can. Next, it's very important, can I square root 16? And the answer is yes. So I'm going to go and set up my two parentheses. The next thing I noticed is the middle is negative, but this is positive. So that tells me that there's two minus signs here. So I'm going to go ahead and square root 9, and the square root of 9 is 3, and the square root of a squared is a. I'll write that in both parentheses. Next, what I'll be doing is I'm going to square root 16. The square root of 16 is 4, and I'll write that in both parentheses. Remember, our middle step was to check that middle term, and the way you do it is you multiply these a and b together. So negative 4 multiplied to 3a is negative 12a. And if I double that, because there's two middles, if I double that, I doubled by adding it to itself, I get negative 24a. Let's go back and check. Negative 24a. Yeah, it's right there. Here's my answer. My answer will be 3a minus 4, that quantity squared. So my answer is 3a minus 4 squared. All right, this is a good example here. because I look at 2 and it's not a perfect square. And I look at 50, that is not a perfect square. Sometimes this will happen. And what I do notice about this is they're all divisible by 2, each term. So I will factor out a 2. So I'm going to write 2 and then parentheses c squared plus 10c plus 25. Now, invisible in front of my c squared is a 1. Next, I'm going to say to myself, is this a perfect square? And yes, 1 times 1 is 1, and c times c is c squared. Is this a perfect square? It is. The square root of 25 is 5. So, I can bring my 2 down, and I can try c plus the square root of 25 is 5. And I'm going to write that twice, and then I'm going to check it. What is c multiplied to 5? And that's 5c. And if I double it, if I double that, times it by 2, I get 10c. And 10c is what I had right there. So I'm ready to write my answer. My answer is 2. I need to use this 2 because I factored it out. And then c plus 5, the sum of c and 5, squared. So it is important, don't forget, after you divide by 2, you do need to include it in your answer. Next, I'd like to talk about the difference of two squares. And before we do, let's remember what that is. If you have a plus b multiplied to a minus b, remember, we did a squared, and we wrote it there, and then we did a or b positive b multiplied to negative b, and that gave us negative b squared. And then the middles canceled, remember, because a plus and a minus canceled. So here's the trick. Look at the first term, and well, if there's only 2 terms, then possibly you can do it. Look at the first term. Can you square root it? Yes. So I'm going to square root it and write a. Look at the second term. Can you square root it? Yes. I'm going to write the square root of 16 is 4. And then what I do next is I know that I need a positive multiplied to a negative in order to get negative 16. And positive 4 plus negative 4 will cancel out to 0. So here's my answer. I do want to show you, you can always do this. You know, I've been talking a lot, not showing you some stuff. I apologize for that. You can always take your negative 16, write it here, and say what multiplied to what is negative 16 but adds to 0. All right, let's try our next one. The square root of x squared is x, and what multiplied to itself is 36, and that's 6. But in order to get a negative 36, we have to have a negative 6 multiplied to a positive 6. So I will have x minus 6 and x plus 6. And that's my answer. Feel free, how about you try this one, p squared minus 49. Try that yourself. So hit pause and try that one yourself. Hopefully you got p minus 7 and p plus 7, because negative 7 multiplied to 7 is negative 49, and if you add them together you get 0. Well, what happens if the coefficient is not 1? No big deal. Here's what we do. We just square root this and square root this and make one a plus and one a minus, but then we check it. So let's check. So I looked at 9b squared and I knew that I could square root that and get 3b. Next, I looked at 225 and I knew that I could square root that and get 15. I also know that there's no middle. And there is no middle because a negative plus a positive will give us no middle. So this is correct. It is my answer. Because I know that negative 15 times 3b will give us negative 45b. And positive 15 multiplied to 3b will give us positive 45b. And they will cancel out. let's apply that to this one. So what's the square root of 25x squared? And what we end up with is 5. The square root of 25 is 5, and the square root of x squared is x, 5x. And then the square root of 64 is 8. Now I need to do a negative 8 and a positive 8 so that when you multiply them you get a negative 64, but when you add them they end up at 0. So hit pause and try and factor out this difference of squares. Hopefully you knew that the square root of this is 2w, and you knew that the square root of 49 is 7, and you made one positive and one negative. Hopefully that worked. Alright, we already talked about this a couple slides ago, but we'll talk about it again. We look at our problem, we see that 5 can divide both of these numbers. So what we're going to do is we know that the greatest common factor is 5. So we're going to divide the 5 out of these. So we'll divide these by 5. And we end up with 5 multiplied to x squared minus 16. Then my next step is to factor this polynomial, or this binomial. So I see that this is a square, and this is a minus sign, so I'm good to go. So all I need to do is write my 5, and then set up my 2 parentheses, and the square root of x squared is x, and the square root of 16 is 4. I know that one has to be positive and one has to be negative. That's the only way I'll get negative 16, and it's the only way that the middle will disappear, a plus 4 and a minus 4. Okay, let's continue. What's the largest number that can divide 3 and 75? Well, it's 3, and when you divide everything by 3, here's what's left. Say to yourself, is this a perfect square? Yes. Is this a perfect square? Yes, and it's minusing, so we can continue to factor. We can go 3 and set up our 2 parentheses, and the square root of c, or c squared is c, and the square root of 25 is 5. Next, I know that 1 has to be plus and 1 has to be minus, for the same reason I stated before, to make this product and to have the middle disappear. Alright, what's the greatest number that can divide 8 and 50? It's only going to be 2. 2 can divide both of those, and here's what's left. Let's check. Is this a square? Yes, 4 is a square, and so is y squared. Is this a square, a perfect square? 25? It is. It's 5. So, let's continue and write our answer. We need to make sure that 2's in front. We'll set up our 2 parentheses, and we know that the square root of 4 is 2, and the square root of y squared is y, so I'm going to write 2y in each of them. And I know that the square root of 25 is 5, so I will write a 5 in each. And remember, just like before, I need one positive and one negative. Let's look at this trinomial. First, I sure can divide everything by 3. So I'm going to do that. And when I do that, I end up with a w squared minus 2w minus 8. Now, hold it. Is this a perfect square? 8. No. So what happens if you come across this? What do? You know what you do? You factor it the old-fashioned way. You factor it the way we learned in the very beginning. What's the product? Negative 8. What multiplied to something is negative 8, but adds to the sum of negative 2. So let's do that really quickly. Well, negative 4 multiplied to 2 is negative 8, and negative 4 plus 2 is negative 2. So we're going to take this and write it into our parentheses. I remembered to bring the 3 down, and I have w minus 4 and w plus 2. And that will give me this trinomial. Here are your practice problems. Please try them all, and remember to factor ahead of time if you need to, if there's a greatest common factor, especially like this one looks like it might, and bring any questions you have to class next time we meet. Take care.